Hello and a very good afternoon to all of you. I'm Anand and it's my pleasure to welcome you all on behalf of eMobility Plus and First View Group to today's webinar on understanding vehicle-to-grid technology, applications and technology overview. As we all know, vehicle-to-grid is one of the fast emerging systems in plug-in electric vehicles such as battery electric vehicles, plug-in hybrids or hydrogen fuel cell electric vehicles communicate with the power grid to sell demand response service by either returning electricity to the grid or by throttling their charging rate. The global vehicle to grid market has potential to grow by 16.86 billion US dollars during 2021 to 2025. So today we are here to understand some of the experts that what does the future hold for this promising segment in India. So here I like to invite Ms. Chandana Shashidharan, Principal Research Associate, Alliance for an Energy Efficient Economy, to start today's webinar with a presentation where she will give us an overall understanding of the V2G concept. So can you please share your screen, ma'am, and welcome to the screen.
Hi everyone, it's my pleasure to be here. I'm sharing my screen. I hope my screen is visible to everybody.
Yes, ma'am.
Yeah. Without wasting time, I'm just going to go ahead. And my name is Chandana, and I work at IEEE. And for the past 3 years, we have been doing dedicated research on the EV side, particularly looking at the charging problem. And the insights that I would be presenting today is part of our work on vehicle-to-grid integration to understand this new frontier for electric mobility in India. So I would start with thinking, why do we really need vehicle-to-grid integration? We all know if you have an electric vehicle, you have to charge it. And unmanaged EV charging becomes a problem to the power grid. Hence, the simplest solution that is available is what we call as vehicle-to-grid integration, which is the pathway to use EV as a grid resource. We would think that this is really simple, but the truth is that there can be multiple layers of vehicle-to-grid integration. You can start with something very simple, which is a time-based electricity pricing without having any controls. That is your basic vehicle-to-grid integration level. Then you can go further up. You can do smart charging where you have control over your vehicle. This could be a simple on-off control. Then you can have additional control, which is aggregated smart charging. Then you could have large-scale bi-directional charging, which is what we say as vehicle-to-grid aspect. And if I want to give you a definition of VGI, I have to borrow it from California Public Utilities Commission, where the definition is quite good. This is about how a vehicle can provide benefits to the grid, the society, and the consumer as a whole by optimizing the interaction of the vehicle with electrical grid. So we hear two terminologies when we talk about vehicle to grid. One is what is called as V1G, which is a unidirectional flow of power. And then there is V2G, which is the bidirectional flow of power. When it is V1G, we mostly call it as smart charging. This includes on-off or ramping up or down of the vehicle charging droids. This could be for a single EV or what we are doing for an aggregated EV. When it comes to V2G, this is bidirectional flow of power, but what we need to understand is it need not always be the grid. That is something that is very critical that determines the success of being able to use electric vehicle as a storage. This can be vehicle to home, this can be vehicle to building, this can be vehicle to a load. So there are multiple possibilities in there where the grid need not be involved. But in overall, what we need to do is V2G can actually offer substantial value to the grid, but it is a bit complex and expensive. Whereas in the current format, V1G can also offer value, but it has limited complexity. The figures in front of you will help to understand this further. If I'm looking at V1G, then I can actually change my charging to a time when the peak power is not there. But when I have V2G, I have the ability to even reduce that power that the peak demand. So that means that the value from an electric vehicle gets extended. So to explain how grid services can be derived from V1G and V2G, I have a simple diagram in front of you. So if a vehicle arrives at a charging point, it is arriving at some state of charge, which is definitely less than 100%. And the services that we can avail from V1G pretty much stops in the point when the vehicle gets full charged. That is, you can actually control the charging rate of a vehicle. You can have a slower version or a faster version, but the service that you can avail from it pretty much stops when the vehicle reaches 100%. Whereas if you have bidirectional charging capacity, you can actually go further down from the 100% charge state. You can go to a lower charge state. And by the time the vehicle is actually departing from a charging point, you can still make the vehicle arrive at 100% or whatever is your desirable charge rate. This is very important to understand, because what we need to say is vehicles actually take a large amount of charging time. Even if it is fast charging, maybe we are looking at 15 minutes, 20 minutes, or even an hour's window. When I talk about V1G and V2G, we are thinking about situations where the actual vehicle parking time is more than their charging time. This could be a vehicle that is parked in a metro station parking lot, whereas the person went ahead to the office and they are coming back after a long period to get the vehicle. So this is pretty critical to understand on the commercial application of V2G. That is, the parking time needs to be more than your charging time. Pre to 2012 is what we could call as the early stages of VGI. 2012 to 2015, we were seriously thinking about V2G, and 2016 to present is where you see a lot of pilots and other efforts which are focused at the commercial viability of V2G. And if I were to take a profile of the global market, Europe is actually leading this conversation of V2G with a larger set of pilots happening there. Second is North America, and Asia in general is third. There are multiple ecosystem benefits for G2G, for the consumer, for the distribution grid in itself. Then I can go one scale up to the bulk power system, which comprises of the transmission system, as well as for the market, whole electricity or energy market itself. If I were doing a smart charging, which is V1G, then I can reduce the peak, I can manage network congestion, I can provide some amount of frequency support, I can even help in uptake of renewable energy by charging my vehicle when the solar power is there, which is important for India. Whereas when I get into V2G, I can do much more. I can think of using storing the renewable energy. I can also think of using storing my energy at a time when the prices is low, and subsequently selling it at a period when the price is high, which we call as arbitrage. But there are technical complexities surrounding it. Three are directly in front of you on the battery health, the smart charger itself having bidirectional capacity, and finally the suitability of electric vehicle, which is really relevant. So as part of our research, we asked the stakeholders, including battery experts, R&D institutions, charging service providers, fleet operators, and others, on what do you think? Like, is India ready for V1G? So we saw more, partially agree or completely agree answers. But when we asked for V2G, people were not agreeing that India was ready for V2G. In terms of technical feasibility, people are more positive about it. But when it comes to the discussion about economics, you can see that people are not positive about this. And this brings me to another point of suitability of the vehicle type. That is, we are going to be a country where we'll have a large amount of two-wheelers and three-wheelers, and they have small batteries. And in case of suitability for VGI, people were of the opinion that they don't agree that this is suitable for VGI, whereas the four-wheelers and the electric buses with larger batteries, they were up and up about it. And one of the major problems that everybody emphasizes when you talk about VGI is on the battery degradation, wherein manufacturers themselves like to say that your warranty gets void if you are actually using the vehicle for VGI application. But I want to tell you that there is another school of thought surrounding this as well, where they say that instead of having a stagnant battery which is not discharging totally, a partial amount of charge or discharge actually supports battery health. There is a school of thought surrounding this. So hence, but the intent of the day is perhaps we need to do more research on that a large set of people agree. And when we asked about the possibility of if Indian fleet operators are ready to do it, we got only partial agreement from them. And when we thought of, can it be part of a larger ecosystem like a virtual power plant, which can operate in India, we got only partial agreements from some people. If I were to summarize this, people think that we should not be talking about DGI straight away because we don't have that many EVs in India. All vehicles are not suitable. We don't have regulatory framework. There is no incentive to do pilot projects. And particularly two more important factors, which are from the technological perspective, that the chargers that you have right now, they are only one directional. You can only give power in one way. You can't take power back. And the larger context of what will be the potential battery degradation. But it is really important because India has a tropical climate. We have very high temperatures, and perhaps the studies done in Europe might not help us. We might need to do further research in India for that. So to give you a snapshot of key issues to be addressed, I'm going to start from bottom up. One of the things that you need to solve, whether it is smart charging or actually getting into the V2G aspect, is the communication part. The EV needs to talk to the EVSE, the EVSE needs to talk to the charge point operator, and the charge point operator or the EVSE itself also needs to talk to the grid. Now you have three sets of communication. There are standards coming up for it. We have agreed on OCPP being what the EVSE and the CPO communicates between. But what about how do you talk to the grid? This becomes critically important. But luckily, perhaps in India, we are thinking in the right direction. We are in a phase where we are developing a standard. We're actually adopting the IEC standard for open automatic demand response right now. The standard is out for discussion. So perhaps we are in the right direction here. But you still need to solve the problem of how the EV and the EVSE are going to communicate. Maybe IS 15108 or another standard could fit the bill here. Then let me come to the standard safety and interconnection aspect. For a large period of time, CHAdeMO was the only a charging system which permitted V2G, and CCS was more on so towards the smart charging angle, and now CCS is also gearing up for V2G. So that's it true that V2G is the future? Perhaps, but there are a lot of hurdles that we need to handle for that. And EVs should actually operate according with the safety requirements, and for every level, the safety requirements and the standards you have changes, and the interconnection requirement for a smart charging and V2G are quite different. And which brings me to talk about the two major problems that is needed, because EVs are batteries in the kilowatt scale. And when you want to provide power system support, they are expecting you to come much closer to the megawatt scale, but at least in terms of hundreds of kilowatt scale. How do you arrive that? You need to aggregate your resources. In transport, we are hearing a lot about fleet operators who are doing transport aggregation. Similarly, there needs to be an aggregation from the demand side, the electrical demand side, these players which can actually bring together a large set of EVs together and represent them as a single resource. And most importantly, before all these things get done, you need to stop looking at EV as just a vehicle. You need to recognize that EV is a grid resource. And this is a very interesting and very funny problem. That is why I thought I will take a moment to explain this. So EV can also be a resource here, and actually your charging point can also be a resource here. If I'm talking about AC and DC charging, I hope you understand this. In one case, there is an onboard charger. So if that is what I want to use for bidirectional charging, then I want my onboard charger to be actually bidirectional charge capable. Whereas if I'm looking at DC charging, it's only a DC-DC interconnect, then in that case, be it a wall box or be it actually the panel outside, that panel which is single directional right now, I need to make it bidirectional. That is what I need to achieve. And if EV along with the battery is recognized as the resource, then I might need to put a meter on the vehicle itself to monitor the transaction. This becomes a problem because now the vehicle, which is actually something moving on the wheels, is becoming a resource. This is not something the DISCOMs have ever seen before, and the vehicles need to be registered to the DISCOM. A lot of problems. My colleague, my friend Siddharth is here, and he can talk more about EV roaming, which will help you understand the complications or the solutions for this problem as well. Whereas on the other hand, if the charging station is the resource in itself, you have lower transactional complexities and you actually have a fixed location for specific metering. And in the third case, as we are talking about aggregation, the resource is actually virtual and it is geographically spread out. Hence, you need regulatory changes to enable this aspect. One of the important questions here would be, what would be the role of the electrical distribution companies here? You can actually have an entire EV aggregation system without the DISCOM in itself, where the aggregators could actually be offering some services to the DISCOM or the wholesale energy market or the ancillary or balancing market in itself. Or you can actually have an ecosystem where the DISCOM is a big player. This is my final slide. So one of the things that I want to emphasize here is one of the first steps that we need to think about when it comes to V2G is that you should have a true price signal for electricity, a time-sensitive tariff that can only encourage the adoption of active control, including smart charging or V2G. Three problems I have covered already. Then maybe I will go to the last two problems. One of the aspects is that if I have an EV, I would rather value it not in terms of the kWh I would get from it, but actually in terms of what support I can provide to the ancillary services in terms of frequency regulation. This is something pilot projects have also shown. If you have an EV, it is more valuable to look at it as a resource which can help in the adoption of local renewable energy or other parts and actually benefit the local grid. Finally, we need to also think of the incentives on VGI. As I said, explained earlier, energy, if I'm only looking at paisa per kilowatt hour terms, I truly don't believe that we would have a market for VGI because these are fast acting batteries which can offer support in terms of capacity in kilowatt itself or aggregated kilowatts in scale of megawatts. What ramping up or ramping down I can offer, or what very quick fast change that I can offer in the power. That could be in terms of kilowatt in 15-minute time block, or actually in terms of kilowatts per second. That is what the value is. Until and unless this value of this, what is the value of kilowatt or kilowatt per 15-minute or kilowatt per second is recognized, you wouldn't have an incentive for VGI. Another major aspect is that the benefits to the consumer need not always be in terms of energy, because I was talking to people who have recently executed a recent VGI project in France, and what we saw that they were majorly giving parking free credits to the EV consumer itself, and that could also be another way that this can be thought of. One final thought that I want to leave you with is that EV, it should not actually be one of the leading causes for increasing of electricity demand in future. But the final thought that we all should recognize is that EV should actually act as a flexible road to support decarbonization with V1G or V2G. People actually say that V1G is a low-hanging fruit, but whereas V2G is revolutionary. But what is the feasibility of both in India? I'm going to leave it to the panel to deliberate. I'm stopping here, Anand.
Thank you, ma'am. Thank you very much for this wonderful presentation and for setting the tone for today's event. Now we move forward with our much awaited panel discussion. And I will start by introducing our moderator for today's session. Shri N. Murugesan sir is having more than 40 years professional experience in the area of power system simulation studies, safety groundings, switch gear testing and development, EV charging and smart grids, etc. He served as Director General, Central Power Research Institute, managing about 35 laboratories catering to power sector. He also supervised about 100 consulting assignments. He expanded evaluation facilities for electrical equipment up to 760 kilowatt class equipment in all units of CPRI across India. He was a member to draw specification to establish EV charging infrastructure in Bangalore and system studies for establishing EV charging infrastructure. At present, he is working as independent advisor to few utilities, organizations, and trainer in the area of smart grid and allied area. Thank you for joining us today, and thank you, sir, for moderating today's session. I'll proceed with the panel. In our elite panel, we have Mr. Ruchir Shukla, Director Electric Mobility Program, Shakti Sustainable Energy Foundation; Mr. Siddhartha Maheshwari, Lead Consultant, EV Charging Infrastructure, Council on Energy, Environment and Water; Ms. Chandana Shashidharan, Principal Research Associate, Alliance for an Energy Efficient Economy; Mr. Sudhasta Kundu, Senior Manager, India Smart Grid Forums; Mr. Amit Kikare, Head of Future Grids, Siemens Limited; Mr. Kuldeep Sani, Senior Security Consultant, Thales. Here, I would like to make a small announcement to all our attendees. If you have any question during the discussion, please post them in the question and answer box instead of posting them in the chat box. And please be specific to respective panelists. We will take all the questions at the end of the discussion. Now, I would like to hand over the session to Mr. Murugesan and like to welcome him and all our esteemed panelists on the screen. Welcome, sir.
Yeah. Good afternoon, friends. It is my pleasure to participate as a moderator. And this subject is very important, though at the nation state, but we need to flag this issue so that in the time to come, it matures and attain its things as in the other sector, like whether it is smart metering or substation automation or power system automation, where these are all similar things happened. The standardization and finding the particular standard to go ahead with that. I think this is also going the same route, and see that it will, I'm seeing that in a short time, it will settle that. So friends, we need not mention about the importance of the electric vehicle as detailed by Chandana Shashidharan. She has mentioned very clearly that. But thing is that we could at present we could able to develop renewable energy in the daytime because of solar and other things. So at present, accepting that pump storage systems, we don't have a very big storage system available, accepting the batteries, and that cannot come to the level of hundreds of megawatt. So this is a small things, and even converting that excess energy developed to hydrogen and all such things. Yeah, yes, they're all possible. But thing is, it's taking time, and so we are at present the daytime excess power development is there. So how do we store it? It's a major things. So thing is that this is also that electric charging is also is a sort of one kind of thing that you, whatever power you develop, that can be slightly diverted so that a part of the daytime things can be utilized. But then again, we see it as when millions of electric vehicle comes into picture, that plays a role both as a receiving as well as it can give at the time of peak load and all such things. So there should be a mechanism and things like that. So when it comes to that kind of communication and all such things, the standardized way of thing is very important, because this is also this is also a building block in this smart grid framework of about 78 layers. So we need to carefully design such a way that this gets into this other building blocks, the back end power network, all such thing. This in a standardized way. Otherwise, again, we need to go down the rough way to going short-term solutions, and again later on trying to etc. things like that. So, friends, this is a very important topic. Now, at least when it is in the nation stage, we could be able to flag this issue, that standardization. Of course, in fact, I was involved with the first time to standardize this EV charging infrastructure in Bangalore. So we also found that time there was no BIS available. then always we look for that international standard in the sense we always look at IEC, because most of our electrical systems, if you look at it, all are based on IEC standards. And once you have this IEC standard, it's easy to integrate the rest of the things, whether you talk about IE 61850 or 62056, 104, or so many protocols also. So they are systematically, they have evolved like that. So this standard also, fortunately, these standards were available as IEC, so we could able to put it. And with that one, now we are getting the benefit. Of course, now BAS also adopted this IEC standard. One is that charging standard. Then next is that when it becomes bigger and bigger in terms of numbers, then then the two-way communication has to take place. Then the standardization comes into picture. So friends, the V2G standard, of course, there are available, whether it's ISO, ECL are available, it has numbers are available. So without losing sight of it, because of each committee, technical committees, different committees under IEC works in tandem with other things. So we should take advantage of that one instead of inventing something other standards. So we'll come back to the standards like that. Even when it comes to that level, the security is a major concern, because this is a low-cost devastation. Anybody can damage the network. So we are opening, as a part of our smart grid systems, we open it advanced metering infrastructure or substation automation, SCADA, and all such things. So the network is completely reduced from vertically to distributed control system like that. But lots of advantages are there, but at the same time, the security is a major issue now. It is very easy to do that. If somebody determined to do that, it is easy. So that security also, we need to address it. I will come back to that as a part of this one, that we'll address that. So my pleasure to participate in these very important things, though things are happening, but we need to keep these things as such a way that finally it ends up in a good thing, the standardization, so that the market expands. Otherwise, the market will become small like that. So friends, Chandana Sashidharan, she had given that presentation. So normally we keep that before introducing the topic, we introduce the speaker. Unfortunately, slightly it went off. I would request, though it has given in the first presentation slide something background, I request Chandana Sashidharan to give a small background about her, so that to the advantage of audience. Then I will come to the next panelist. Kindly, just Chandana.
Thank you, Murugesh sir. So my name is Chandana. I work in a vertical called as Power Utility and Electric Mobility vertical. I'm an electrical engineer and my master's is in renewable energy. But I am proud to be working in the EV space right now. It's all interconnected as I see it. So our research is mostly focused on how the electrification of demand is happening in India, how it can be handled. And we study EV from the perspective of how can we nudge electric vehicle adoption, as well as largely also from the perspective of vehicle to grid integration. That's all.
Thank you very much, Chandana. Of course, I have privilege to introduce small. I know about Mr. Ruchir Shukla. In fact, I also worked to a small project with Shakti Sustainable Energy Foundation on EV charging infrastructure like that. So, sir, I'm very happy that your institution is doing a lot of things. Many people do not know that you are all funding many things which really help this society. So I request you, sir, though I know that company like that, I request yourself to give a small brief about yourself, so that it will go like that.
Thank you very much, Mr. Murugesh, for all your kind words. And we are just, doing our part of work, nothing more than that. So let me quickly take this opportunity to have people for the benefit of those who don't know. I come from organization named Shakti Sustainable Energy Foundation. Shakti is a not-for-profit organization. It's headquartered here in Delhi. Shakti is supported by both Indian and international philanthropies, and we execute projects, including research work in partnership with our large pool of CSO partners, NGOs, universities, think tanks, and many subject matter experts, both in India and globally. Shakti works basically to facilitate the transition in India to a cleaner energy future, sustainable future, by aiding the design and implementation of policies that promote clean power, energy efficiency, sustainable transport, climate policy, clean energy, finance, and electric mobility, which we are talking today. And specific to the electric mobility initiative, it's a multi-funder platform which mobilizes all philanthropic efforts with an aim to accelerate electrification of automobiles with the goal of making 100% decarbonizing all transport sector by 2050 in India. So EMI engages with key stakeholders, as I mentioned, across various CSO partners, government regulators, industries, all sorts of way of life, with core mandate to support transition of transport segment to all electric. And we implement solutions for the electrification of not only the transport, but also its reach or connectivity with the green sources of energy. And we promote cross learnings through our national and subnational engagement, as well as leverage international best practices. So thank you for this opportunity.
And also, sir, we request you to give your views on the things like V2G things are with electric vehicle itself. You can give your opinion if there is anything like that. You mentioned it, of course.
So shall I go ahead about talking on the topic we had?
Yeah,
oh, okay. I thought it's a round of introduction. My apologies. So
no, maybe short so that the next speaker will introduce. Then you can tell that. That way we'll do that.
Okay, thank you. So I think this is a very, very interesting topic, and I don't think anything left after what Chandana spoke and you have mentioned. But I'll just try to catch some of the pieces. I think one of the very important aspect here, what we believe is awareness and adoption. So nudging the consumers, bringing the OEMs and all key stakeholders to the common understanding in terms of them understanding this really the large gains. Now, where are the gains? As Chandana touched upon a few points, and also some of the apprehensions and issues where I think mentioning that OEMs or battery manufacturers have possibly a concern. Certainly everybody wants the minimum use of the product sold out, right? So that the warranties are best covered. But when we see that whole system is maturing and reliability is gaining up, and batteries today give, depending on the charge cycles and the way they are designed and packed, they are easy giving 8 to 10 years of life, right? And that is where the whole beauty lies. Electric vehicle and associated ecosystem, if I see, somehow it comes as a big boon in this today's scenario where we are going to be solving not only the emissions related thing, but also issues related with IC vehicle. What they really throw on the ground is huge heat. So here having also the larger portion of storage component all along, and vehicles by nature are distributed across cities to towns everywhere. What we are seeing in future 8 to 10 years is going to be a decentralized power, which people have envisaged in the renewable energy, whether it's rooftops and all, supplemented with built-in storage, be it a smaller two-wheeler all the way to, especially when we are talking about the sizable vehicle. And as we move in 5 to 8 years, 10 years, they're going to be secondary use batteries, repurposed batteries, And they'll be much more effectively bridging the need of balancing or giving a shock absorber phenomena for the grid. So here, what we look at it from the power quality standpoint, if I say, related with regulation of frequencies, reactive power arbitrage, right? So that's another big opportunity where, as Chanda mentioned, as we become like too smart with such a dynamic pricing, which is all computer managed. So depending on the people who have the type of vehicle and depending on their daily use pattern, artificial intelligence itself will take over to really do that arbitrage and bring a effective earning of anywhere from say $100 to $200 on an annual basis, per a typical vehicle car, right? So that's something as kind of advantage showing up. Apart from that, it also gives multiple advantages of taking the renewable sources, because today, what is grid? Grid is just an electron has to move in and somewhere it has to be consumed, otherwise it has no room to get stored. So providing a grid scale storage in the decentralized network of system, vehicle become an integral part, and therefore the capex comes down when you're realizing a grid which can really take care of all connecting vehicles, be it at the home or they are at the office space, leaving that when they are truly in use on the road. So rest all the period, if they are hooked on to the grid, whether it's microgrid, DC grid, AC grid, we have huge support, and therefore the capex can be really well optimized, and this advantage can be accrued very well. Also, the charging phenomena can be more effective and thereby reducing the peak power requirements, which otherwise will get loaded on. So here on the opportunity, because of V2G, we can also take the power one end, which is anyway needed. And when there is a need at a larger tariff, which we talked about as power arbitrage, the vehicle can possibly return back. The peak power situation, when really there's a need to support the grid rather than making some of the non-critical load to get off to control the peak needs, these can be alternate options which DISCOMs and other power agencies who can use it. Therefore, when they are decentralized V2G connected, your T&D loss is going to be coming down. You are going to be seeing a home to mohalla to cluster base, lot of transaction happening within that zone rather than making large power to move from one point to coming to other points. So that's another big advantage which I see. Therefore, it's also going to be helping in creating a more greener or decarbonization of the grid. That's another thing which I look at it. Now, while we said all that, the good talking going on hybridized kind of a distributed network, right? Where you have a multi-source of power getting linked up to a so-called common grid. They may be tomorrow connecting with, like today itself, we have fuel cells and other options which can possibly add on to the present network of where you have solar and other. The solar and many other renewable sources are not predictable. And therefore, the storage and another end is, instead of firing the coal-based plant, you have these options to really jump up to the very fast time-based response and really help balancing the overall grid and ensure the power availability is there for the critical loads or the consumers who are really needing that point in time. So DRs going to be, distributed energy services going to be using a lot. And I think overall, this whole process demands, certainly, as you also mentioned, very strong communication, secured communication, right? Cybersecurity, like I was talking to at home a couple of my friends here. Today, we have all something like 500 to 1,000 rupees per year for the name of antivirus to our mobile or this and that per system per person basis. 20 years before it, there was nothing like it. So we believe it's going to be generating a lot of other challenging environment and opportunity. One is responsibility to create a secure network, because any flexibility comes at the cost of a threat which is embedded in. It's like head and tail. You can't have a single phase coin, and that's where it gets in. And having here what we talked about, new opportunities, new skills, and new skilled people coming to this mainstream work. All this is possible with the last line. What I have is only the collaboration, which is collaborative way of working across all stakeholders and key players in the market. Thank you very much. I'll pause here and look forward. Thank you.
Thank you very much, sir. Thank you very much. Yeah, the Shakti Energy Foundation is doing extremely good work in funding. That is very important at this stage. Doing good work. I wish you all the best. Gentlemen, we'll move on to next speaker, next our panelist, Mr. Siddhartha Makeshwari. He's a lead consultant of especially electric vehicle charging infrastructure and working the Council on Energy, Environment and Water. So people will be knowing about CEW. I request Mr. Siddhartha Mageshwari to just give a brief background about himself, the organization, and maybe he can take about 5 to 7 minutes to tell his view on this particular topic. Over to Mr. Siddhartha Mageshwari.
Thank you, Murugesan, sir, and wonderful to be here as part of this esteemed panel. My name is Siddharth, and I'm part of the Council of Energy, Environment and Water, which is a climate think tank based out of New Delhi, which works in areas of decarbonizing India. Specifically, my work over here at CEW is to advance electric and other sustainable forms of mobility and encourage their adoption within India. And we work with a variety of stakeholders, both in the public sector and private sector, to move the market forward in terms of electric mobility. Just to give a couple of points here and add to the discussion, we obviously heard from Chandana, and thank you, Chandana, for setting the wonderful basis for our conversation. I just have a couple of points to add to your presentation that you had given earlier. The first point I wanted to make is that whenever we talk about vehicle grid integration, the central stakeholder in any of these initiatives is actually the distribution company or utility. Unfortunately, in India, in many states or many parts of the country, the distribution utilities are also the weakest link in the electricity chain, and because of that, there is a lot of inherent, I would say, inertia to adopt new technologies such as renewable energy or rooftop solar, or even aspects such as electric vehicles. So strengthening this chain and increasing their capability to adopt technologies such as V1G or V2G is extremely important if we are to talk about implementing this concept at scale in India. The second point I wanted to make is that is the significant point that there is several layers that exist between normal unmanaged charging and V2G. I think Chandna had an excellent slide that provided these several layers. I just wanted to highlight one fact that between V1G and V2G, there are also a couple of other layers where you could have vehicle to load, vehicle to vehicle, or vehicle to house. So there are a couple of other applications that exist, and actually, in some cases, these applications are much easier to implement in comparison to the grid. Injecting power to the grid requires a lot of regulatory, technical, and commercial work before that is done. But however, if you had to transmit power from vehicle to vehicle, that is fairly easy, and there are vehicles today like the Hyundai Kona in the Indian market that are able to do that. And I definitely see the potential for greater work to be done in this area. Say, a vehicle that obtains power from the microgrid, but also supplies to it. The third point I wanted to make is the market segments in which vehicle grid integration could be implemented. So as Chandna rightly pointed out, India's EV adoption is actually led by two-wheelers and three-wheelers, and because their battery capacity is limited, you need an extremely large volume of these vehicles to make a measurable impact on the grid. However, there are some niche areas where this might take place. So battery swapping is actually one example where even though the battery is outside of the vehicle, it can act as a grid resource to stabilize the grid by providing some of the balancing services that were earlier talked about, whether that's peak shaving, frequency regulation, arbitrage, etc. The other opportunity, I believe, lies in electric buses. Again, because they are many times owned by state-owned entities, they are concentrated in certain bus depots and they have a very large capacity. Again, they could potentially act as a segment where vehicle grid integration may be implemented first. And lastly, even though a lot of the discussion that we've had till date is about the challenges for implementing a VGI or V2G, that shouldn't stop us from at least trying out some of these technologies and implementing them in Indian conditions to see what their potential lies. There's definitely a lot of potential for these technologies to help the Indian consumer and the Indian grid. And I look forward to the discussion today to learn what other panelists think about the subject.
So thank you very much, Mageshwari. And it is very nice that you have given your views. And next, I'll go over to Mr. Amit Kalkere. He represents the Siemens Limited, and he is the head of future grids. And it is very important that Siemens is driving many of the things like whether you talk about substation automation, grid automation, you name anything, they are in that space. So I'm extremely happy to invite Mr. Amit to come over here because they have a wonderful experience with the rest of the domains also, which is very important, the smart grid area. I would request Mr. Amit to give a few words about your background for the benefit of audience. Then you can go ahead with your views, maybe about 7 minutes, 7 to 10 minutes, you can go then we'll come back.
So good afternoon, everyone. Thank you, Mr. Murugesan. It's a pleasure to be on this panel and share the views with esteemed speakers from different walks of ecosystem. Siemens, I mean, just as a background for me, I'm heading a business called Future Grids. The reason we call it as Future Grids is because we think that energy transition is actually moving closer to the edge of the grid. And this grid edge technologies like the renewables and the electrical vehicles are going to shape the future of our grid structure, grid infrastructure, and grid use cases. So under Future Grid business, what Siemens is basically focusing on are 3 legs of the portfolio. One is electric mobility, EV charging. Second is grid scale battery storage, which is basically lithium-ion based battery connected to the grid to provide a lot of ancillary services and further solutions. And third one is obviously the solar, PV solar, central and string inverter kind of focus. My background, I'm responsible for this business for India and Middle East, been in the electrical industry for more than 17, 18 years. Electrical engineer and power system engineer by training, but over the last 10 plus 15 12 years plus been handling different responsibilities, including strategy and new market penetration. So in this context, the Future Grid is very, very interesting topic for Siemens, and the reason Siemens is also walking the talk is basically Siemens has committed to be a carbon climate neutral basically by 2030. So we are also implementing many of these technologies in our own campuses and demonstrating that it does make sense to shift the gears towards more climate friendly technologies. Now coming to the today's topic, as Murugesan sir and Ms. Chandana and my colleague Siddharth also referred to, the V2G. E-mobility in India is indeed a very, very exciting topic. It's at nascent stage. It is picking up. It's making rightful impact in key segments, two-wheeler, three-wheeler, and on the e-bus side. The passenger vehicle pickup is still lagging compared to what we would like to have it. However, now looking at those two segments, the two-wheeler and three-wheeler. So when we are talking about vehicle to grid kind of concept, right now, as Ruchir sir mentioned about awareness is the first step. So many of the citizens of India and the users are right now only in the awareness phase to actually adapt the e-mobility or EV as one of the option for their mobility or transportation use. I think V2G is still few years away. The reason being majorly the end user is grappling with the range anxiety. So the combined use of the asset of battery inside the vehicle for use of grid support or any other application is a concept which the end user has to still adapt, and that's a step two, where Ruchir sir also mentioned that some sort of a monetary benefit of $200 per year kind of can be achieved. These things need to be implemented not only through government subsidies or something, but from the DISCOM's different regulations and tariff policies. We are, as recent as last 2 months ago, CERC released the use of battery storage as ancillary services for grid level. So we can imagine that how much time it will take if we go through the regulatory route to come for vehicle to be used as a ancillary services as option or asset. So it has to go in a multiple faceted way. Yes, we can wait for the government and the DISCOMs to lead it, but there are also options like vehicle to vehicle, as Siddharth was mentioning, vehicle to vehicle or vehicle to home. There comes the new technology part of it, more towards the peer-to-peer energy transaction. And why we are also mentioning such kind of technologies is the energy which was in previous life was unidirectional, now been really not only bidirectional but also peer-to-peer, which is the DISCOMs are not even engaged into the transaction. So this kind of energy transaction needs to be encouraged and need to be, let's say, piloted, at least in context of India. There comes the blockchain and all other fancy technologies to actually make it materially possible. And Siemens proudly indeed involved in all these three examples. So I would say V2G, we have indeed couple of projects. So one in Netherlands with VDL for with Solaris buses. We are trying to showcase the vehicle to grid technology works fine. Also, we have done it in one of the Berlin campuses, EUREF, where we are showing the microgrid works, where we have a software also controlling the bidirectional charger combined with the renewable energy battery storage and a small battery storage and solar plant, basically managing multiple energy resources. And when coming to the peer-to-peer energy resources, we have done such kind of thing in New York City, where peer-to-peer energy transaction was enabled. So as a company, Siemens is been driving the innovation in many parts of this ecosystem and many parts of these technologies to make sure that this works. When it comes as a head of business, then comes the question of not only technical feasibility, but commercial feasibility. And that's where one needs a lot of push from technology players, including the OEMs, vehicle OEMs, the infrastructure OEMs or equipment OEMs, to make sure that we standardize the manufacturing or the communication and protocols, so that interoperability becomes much more easier, implementation becomes easier, and the scalability can be achieved in shorter period of time. Hence, I think that would be one of the key part, I think, to make sure our any e-mobility revolution, whether it is V2G, V1G, V1G, or every part of vehicle electrification of vehicles would be dependent on. And as a part of the ecosystem, we are definitely happy to lead it as also with all esteemed ecosystem players. Yeah. So I'll stop here and then answer the questions in the question answer session. Yeah?
Thank you, you very much, Hamidji. Go over to Mr. Sudhasata, Senior Manager, Technical Advisory, and is working for Indian Smart Grid Forum. And incidentally, I'm also an advisor for Smart Grid Standards group. I know this organization very well because I am also one of the founder of the organization way back in 2010 with the Ministry of Power and other things we started. And this IAGF is driving this single organization identified in India to drive this smart grid initiative, and they are doing extremely good work in terms of all the components of the smart grid, whether you talk about advanced metering infrastructure or smart metering or substation automation or grid automation or vehicle. They are in all this space, and they are doing extremely good work in the last 12 years. And I will request, because I know this organization very well from the beginning, I just giving that background. And I request, I also worked with Mr. Sudhasata of the many projects for even Shakti Sustainable Energy Foundation also. So I request Mr. Sudhasata to give a brief background about himself. Then he can go about 7 to 10 minutes about this particular topic. Then we'll open up. Over to Sudhasata.
Thank you, Murugesan sir, and very good evening to everyone, every panelist on the panel. And myself, Shuddha Kundu, I am working as a senior manager with India Smart Grid Forum. India Smart Grid Forum is a public-private partnership of Government of India, Ministry of Power. And we normally work in our mandate is to help government and state and other regulators to facilitate them in regulatory and policy issues, and also along with the implementation roadmap and other things. So we normally work in the area of smart grid, electric vehicle, energy storage, renewables, and blockchain applications in the energy sector, and etc. And my role is mainly to look after the consulting practice mainly on the smart grid and electric vehicle side. And we have implemented or facilitated West Bengal Transport Corporation in implementing 80 charging stations, which is first city in India to implement successfully 80 charging stations in India. So we are also working on the vehicle to grid integration aspects. In few of the aspects, we are in touch with various University of Delaware, which is one of the premier institute in designing the vehicle to grid integration projects in the US. So this is about ISGF and me. And now over to the topic. As Chandana, Siddharth, and Amit has already mentioned the benefits of V2G, and Mr. Shukla has also given what needs to be done from the awareness side, and what is the benefit mainly on the ancillary service, frequency regulation, peak shaving, and all those things. But there are a few that I want to add on those, what need to be done and what aspects need to be considered before moving on to V2G and V1G. And Murugesan sir actually worked with us in one of the projects in Bangalore, that is under Shakti Sustainable Energy Foundation, on the charging stations planning, where we have carried out load flow studies in various areas and various feeders actually to find out the exact location of putting up charging stations, so that in those feeders there is no impact on the power quality, and the with rooftop, those feeders with rooftop solar power are also there. What is the impact of the charging stations in those feeders when the rooftop solar power generation is already available in those feeders? So there we have found out various issues in terms of harmonic generation and other things. Although when the rooftop solar generation is on the higher side, that the impact is very less if the EV is getting charged. But on the other time, when the EV is getting charged, the power quality is getting impacted in the generation of harmonics. But the TDD is already within limits, but the THD is increasing, or it's above the what is the IEC limits, IEEE limits that has been prescribed for the harmonics. So if you see that if we are trying to balance with V1G or smart charging or V2G, what is the renewable energy electricity generation, we also need to understand the impact of V2G on the grid. It's not also on the power quality, because EV and the charging stations are non-linear loads, and these are not producing any sinusoidal AC curves, which can be easily, where we can say that the power quality, there will be no impact on the power quality. So we need to understand that how we need to design the market structure or the time of use pricing, what Chandana has mentioned already, how we need to design the TOU when we are putting up the V2G aspects there, right? Because V2G will also, we need to, as you mentioned, that we need two-wheelers and three-wheelers are the prime source for the V2G, and we need, as the battery capacity is low. So we need to aggregate those resources before putting it as an EV resource to the grid to have an impact on the grid, what we say. So for that, we need to understand what should be the market structure for that, how we can aggregate those resources at one time to produce such a huge amount of energy that can impact the grid, that can have an impact on the grid. So the TOU should be designed accordingly. The aggregators, the rules and regulatory policies should be designed. There should be incentivization on that side so that the aggregators are incentivized to aggregate those loads at certain point of time. And not only aggregators, the customers or the EV owners are also incentivized. So they can understand that, okay, this is my benefit and we can give my EV as a resource to the grid at that point of time. So in this way, the power quality can also be improved on the grid, because if the TOU and this incentivization is done accordingly, then we can, what you call, complement the renewable energy generation. And with rooftop solar generation or the distributed energy resources are getting pumped up and increasing day by day, so we need to plan these resources accordingly. Secondly, what Amit was saying on the peer-to-peer, as that is not an impact on the grid, and if we can do that on the peer-to-peer, already ISGF is doing such a project, and we, along with TPDDL, Tata Power Delhi and EPCL, we did a peer-to-peer trading of rooftop solar through based on the blockchain platform. So in the TPDDL project, we included charging stations also in the blockchain platform. So along with the rooftop solar, the charging stations, it's not a V2G, it's a normal, the charging station is procuring power from the peer-to-peer thing. But if the V2G charger or bidirectional charger is there and the load is or EV is connected to that charger, we can easily include that in the consumer or the prosumer list, where that EV can share power on the grid, on the two other peers actually, on the many consumers on that. So that can be done on a peer-to-peer, vehicle to building or vehicle to vehicle, or other things we can improve on, we can facilitate through this blockchain and other things. But also for the vehicle to grid, we need to design, we need to create a properly, or to design a proper market structure where the TOU and incentivization to be done. If you see the ancillary service market in India right now also, energy storage may be included right now, and that too at the transmission level. And EVs will be mostly aggregated at the distribution level. When we put up a ancillary service at that level, what requirement, regulatory requirement we need, or the grid code, there may be changes in the grid code when we'll be putting up a distribution level resource to be connected to the grid and then putting up ancillary service. So it's not so much easy that we talk on that it will pick shaving and all those things will be done. Ancillary service, we can do frequency regulations. So although on the technology side, although OCPP communication, other standards have come up and we can connect OCPP 2.0.1 with OpenADR and can directly connect to the grid. So those things are already going on parallelly, but we need to understand on these things. And as Mr. Amit said, we can first go to the peer-to-peer thing if you have a bidirectional charger or a CHAdeMO charger, which are facilitating V2G. That will be the most easiest way to do that. And then we can go to the grid, because grid needs a huge amount of energy to have an impact on the peak load shaving and frequency regulations and all those things. And ancillary service market, you see today also the incentivization is not that much that you can go and easily grid and resources will be aggregated. So all these things we need to be taken into account when you're talking about regulatory, market design and everything, if you are really trying to have the vehicles having a proper or a large impact on the grid through this. So with this, I will stop and we'll wait for the questions and answers. Over to you, Murugesan.
Yeah, thank you very much, Sudarsada. We have worked on this particular area very closely. Friends, next I'll go over to Mr. Guldeep Saini. He's a senior security consultant from Thales. I'll request Mr. Guldeep Saini to just introduce himself as well as his company and what is he doing in this area. Then he can take another 5 to 7 minutes, so that at least we have 20 minutes time to discuss about question answer sessions. Over to Mr. Guldeep Saini.
Yeah, thank you, Murugesan. Thanks for this opportunity, and thanks every panelist for setting the pace. And I think pretty much covered in this space. And I would be covering more on the cybersecurity aspects. My name is Kuldeep Saini. I have been working with Thales in India for almost 13 years with Thales, and overall 17 plus years in cybersecurity. Thales is a global leader in the advanced technologies like big data, connectivity, artificial intelligence, quantum computing, and they are also working in the defense, aeronautics, space, transport, and the cybersecurity space. So what Thales is doing in this space is providing the connectivity module and making the grids more smarter with connectivity. They are connecting the head-end systems to the cloud, so that the discoms are not facing any difficulty in terms of connectivity, and they are collecting the data from the smart meters and from the marketing perspective, and updating the devices over the air, and more on the vehicles. When it comes to the vehicles, Thales is also providing the connectivity modules for the vehicles and for the charging stations as well, because the vehicles are becoming now more and more smart, and with the electricity and EVs, they need to be connected with the charging infrastructure, and charging infrastructure in terms it will be connected with the grid as well as to the cloud, so that it is more digitized and collecting the data from the charging station in terms of the utilization of the charging infrastructure in that parking slot, and things like that. And they are also sharing the data to the vehicles for V2X purpose. When the vehicles are connected with the roadside infrastructure, the vehicles are fetching that data and collecting that information, that which parking lots are free for the charging slots, and where they can park their vehicle. They can see that information on their car's infotainment system. So that is the pretty much area where Thales is working on the connectivity, on automotive as well as on the power sector. There are a few primary concerns when we talk about the V2G. It is more now the PLC communication, because we used to have the combustion-based engines. When we are going to the fuel station, we just get the fuel tank top up and we are done. Now, when it comes to the EV is now more connected to the charging infrastructure. And when the external component is now connected to my car, I am more concerned that if something malicious is being injected into my car, and my car will behave differently, and because this is now a safety concern for me, that if any firmware or if any software on the car ECU is being modified or being tampered. And same is the case with the charging infrastructure and the grids and connected cloud as well. For example, when there is a malicious intruder who is now connected through the power line communication, where there is a IP stack on the PLC layer, and when they injected the malicious code into the charging infrastructure, this is a loss to loss for the charging operators, charging to the infrastructure owner. Right. So this is where the cybersecurity comes into the picture, that the vehicle should authenticate the charging station, and charging station should also authenticate the vehicle, because it might happen that as an intruder, I might be connected. Instead of car, I might connect to the charging point, and same is the case with the vehicle. And we might tamper a lot of information. So, and same when it is it is plug and charge is a new concept, where I don't need to worry about the payment and all that, because there might be some different ways to authenticate. And for payment perspective, like there are mobile OTPs. When I authenticate myself as a car owner with the charging station, I will just authenticate using the OTPs, and I will make the payment for the consumed power which is used to charge my vehicle. there is a different way that I don't need to worry about the authentication part, because that is where the PKI, the public key infrastructure, in terms of the cybersecurity, that comes into the play. And that is where the Thales is providing the consultancies to the vehicle OEMs, and providing the consultancy to the discoms and the charging operators to implement the robust cybersecurity, and providing the encryption devices for encrypting the data and deploying and in the cloud, and protecting that data in the cloud. So this PKI, using this PKI, the vehicle will be authenticating the charging station, and vice versa. The charging station as well will authenticate now the vehicle. But going along with this, we will have now more in terms of the investment. As an owner, as a vehicle owner, how does it impact me? If we implement the cybersecurity, or if we implement the charge and plug and charge, of course it is convenient for me. I don't need to worry about the security issues. I don't need to worry about the payments, whether this channel is clear, or some intruders can hack it, or they can steal my credit card information. I don't need to worry about that, because this channel is now on the IP stack. It is over the TLS. It is protected. But it has its own cost, because the same infrastructure has to be implemented in the car ECU, the EV ECU, and same infrastructure has to be owned and implemented in the charging point. And we need to have the robust PKI for supporting this authentication media, authentication mechanisms. And that is where the ISO 15118 comes into the play. There are different parts here which can consider the flow of the communication over the PLC communication layer, and how the messages are to be protected over this layer, and how the firmware. So for example, in the digital era now, when we use a lot of software components to implement different features, these features comes with the vulnerabilities. The researchers keep on working on the different vulnerabilities, and they keep on reporting. We cannot live with the open vulnerabilities on charging stations or on the vehicles. Let's say if we have charging station with the vulnerable component, of course it has to be protected. It has to be updated with the new software components. And it is difficult for the discoms or for the charging operators to update these charging stations manually, going every city, every street, to update these components manually. It is not possible. So how the ATM machines? So look at the ATM machine example. No, people are not going there. Banks are not going there physically. They are not changing the keys. They are not changing the software manually. They just push the update, and all the ATM machines are updated. The same infrastructure has to be developed for the charging infrastructure as well. Whenever we see any issue, any problem, or any vulnerability in the charging points, we need to just update them with the latest software, with the fixes more often now. So with this, I will stop speaking more on this, because we are short of time now, and I will hand over back to Murugesan. Thank you for this opportunity to talk about the V2G and the concerns about the cybersecurity. Thank you.
Yeah. Thank you very much, Kuldeep Saini. Thank you very much. Though our the presenter Chandana Shashidharan, she gave a presentation, but she has not given her view on that. Maybe 1 or 2 minutes she can take to tell her view on this particular topic. Chandana, are you there?
Yes, sir, I'm here.
Yeah.
It was great to listen to all of you today, because I understand we have covered different aspects of the ecosystem. And when I come back again, I started the conversation, and towards the end, we can see that we have covered multiple aspects, which makes this conversation very enriching. Perhaps the last 2 cents that I would like to add is that one of the things that we need to realize is we should do it right the first time. the approach towards V2G or V1G in general should not be that let some EVs come into the picture and then there will be a problem, then we will try to solve it. Because if I look at the power sector in India also, it's actually after a 2012 blackout that we realized reliability is a huge problem. And then we started fixing it, and we have become a long journey when we stand at 2021. That is where the entire concept of smart grid has started in India. And because of the fact that our power grid in itself is becoming smart, this is a huge advantage that we have here. We should actually strike our iron, when the time is actually right, and we should realize that the time is right now. Like when we roll out these programs in India, we should always factor in these conditions, particularly as Siddharth also pointed out, when I talk about vehicle to vehicle or vehicle to home or vehicle to a building. These are critically important, and these are interesting aspects because there is also an interplay that is possible with even rooftop solar systems that comes into play, which will ultimately help in the decarbonization of the sector itself. And the final thing, when I look at charging in itself, there is enough smartness in the charging system as I see it, because the payment that happens with any charging infrastructure is quite safe in nature. There is enough cybersecurity and all sort of concerns that are being addressed there as well. The only thing that perhaps we need to do is we need to widen our thought a little bit and bring in that amount of amount of thought that we are giving onto the back end also towards the electron aspects for it, and ultimately also think of a framework that is scalable, which can actually encompass all sort of players. So it should not be a case for buses alone. It should be also a case where a two-wheeler can be integrated, because if I look at a two-wheeler battery, it is perhaps of the perfect size to provide support to a home in India where we actually have lower consumption. Whereas a bus in itself, if I'm taking the case of a school bus, it's an electric school bus as a case we have seen pilots where they were able to support the institutions in itself. So our canvas is quite wide, and my leaving thought definitely is that the ultimate aim of having transport electrification, be it through hydrogen or be it through direct electricity itself, is decarbonization, and we're all concerned about emissions. And without actually emphasizing and without actually ruling out VGI, we are going to be not going to be able to achieve our goals. And the final thought that I do have is that it doesn't take one person. It actually takes a collaborative effort from a larger set of people to do this. Thank you, sir.
Yeah, thank you very much. Thank you very much, Chandana. Now, what we need to say that we mentioned about many things. So here, what happened? When we started with the one standard, that charging. But there are a host of standards available. The host of standards, host of requirement to be met with. It is not a small charging or battery charging or giving power like that. So a host of standards are there released by IEC to address various requirements. So that need to be addressed to all stakeholders, whether an end user or otherwise the discoms like that. So friends, as Mr. Guldeep Saini mentioned about it, that regarding security, yes, a very important part here, because we are all electrical engineers, so we know that it is not that we see as a small equipment, but it has to do a lot of things at the back end. So friends, there are standards because we are also trying to sensitize our own fraternity regarding this security aspect of that, whether we talk about ISO, IEC 27000 series. Then when we come to these equipments, the equipments are operating on different protocols. We talk about communication protocol like a 60870, that 104, or ICCP protocol or IEC 61850, we are all talking of the equipment related protocols. Some of the protocols are not designed to take care of this security aspect. So that then that IEC has come up with a different standards called IEC 62351 to address that protocol specific deficiency, how to address that. So friends, these standards also to have to go through that. When we talk about the security aspect, as Mr. Saini mentioned about the 15,118 standard talk about communications. There, in addition to that, we need to take care of the other aspect of security also, because this communication need to interact with these power systems at the back end. So friends, when you talk about security systems, we need to address, in addition to communication like 15118, and we need to take care of the standards like ISO IEC 27000 series, as well as that series IEC 62351, which is specially meant for the power systems. So that is one part. Next comes that for the benefit of our audience, we need to mention that what standard we need to go for V2G. Though we are not a very nation state, but this is the right time to see that this is also opened up, so that we also align all our product and services, all such things in align with the international practices. So I'll request our panelists to throw some light on, though we know some of the standards, like in fact, we also advocated some kind of open standard, because the open standard is the only way to do that. We have already given a type of report to especially Shakti Energy Sustainable Foundation like that. But I'll request any other things from panelists to the benefit of our audience. You can tell about the numbers, that standard, whether it is OCCP or other IEC standard, which is to be adopted for our future. Over to panelists, then we'll go to the audience.
Sir, I think OCPP is already just started develop the OCPP 2.0 and 2.0.1, and they're also given the OSCP, which is the Open Smart Charging Protocol. And OSCP can forecast a 24-hour, means day-ahead load forecast. They can do that day-ahead electricity availability forecast for the charging stations. And charging stations, I think through CMS, they can plan when to charge those electric vehicles which are coming to that particular charging stations, or group of charging stations that is connected to that CMS. So OSCP, the Open Smart Charging Protocol, is already there. So that can do that. And OCPP 2.0.1 is, I think, is currently working for this V2G, and they're also being integrated with Open ADR. They're working with Open ADR for this connectivity to the utility, OCPP 2.0.
Yeah. That we need to tell to this benefit of the audience that these numbers, so that we may not say standards like IEC ISO 27000 series or IEC 62351 or IEC 61850. Nobody can become master for a short period of time, but at least when we are in the sphere, we need to know the numbers, at least to see that in the developers or manufacturers, they are expert on the particular standard like that, they will deliver it. But as an end user, we should know that these are all the standard, these are all the numbers, so that your whole thing is taken care of it. So thank you very much.
Just to add on PLC, if you plan to support PLC communication and you somehow are not going to support plug and charge, then knowingly or unknowingly, our developers might leave the IP stack there. Just take care of that. Do not leave the IP stack there, because it opens up the attack surface for the adversaries, and it will open the easy route to get into your charging stations. So just avoid leaving the IP stack open if you do not plan to support cybersecurity along with the plug and charge.
Okay. Any other standards? Okay, we mentioned about OCCP2 like that. Can you specifically mention that any other standards like IEC or anything they have done on this particular activities? Because end user, we need to give them the numbers, because they may not know the total
Yes, exactly.
nitty-gritty of
So
the
from
things like
from cybersecurity point of view, I think ISO 15118 is very important
yes.
to support plug and charge technology.
Yes.
Which is upcoming in the European countries and Western countries. This has already been adopted, and now OEMs are working to support the plug and charge on board.
Yeah, this is international
This
IEC
is very
standard,
important understanding.
IEC standard also. So there is no problem for us to adopt any of this IEC or ISO standard directly, because most of the standards are interlinked with this two organizations. So that is one. Any other view, my co-panelists, so that we'll throw open to our audience maybe 5 to 10 minutes to tell about it. Okay, Anand, now our panelists have given the views and the standards numbers, the very many standards we talked about it. Now it is open to the audience to field a question, so that
yes, sir. You can check the question answer box. There are two questions. There are three questions the attendees have asked, so you can ask.
Yeah, you can tag it. You can.
Should I read it out?
Yeah. One by one, you kindly read it.
So the first question is, I'm reading it out. As we are trying to find out solutions to the uncertain and intermittent renewable energy generation, and thinking of V2G as potential option to flatten the peak loads, I would like to know how we are going to handle the uncertainty coming with the V2G technology, as we cannot assure about the certain amount of energy that we can avail from the vehicle.
Panelists, anybody can answer that? Otherwise,
well, let me try. I think the question has a bit confusion as well. What, if I understand correctly, the question says, as the present time, if the electric vehicle, they don't have much clarity, what size, capacity, batteries in there, possibly that's what I'm understanding this question, and how they can solve that another problem, which is again uncertain. So I would answer in a very simple way. One side in the standard in our power generation, transmission, distribution, it's connecting a number of switching loads by a number of generation plants, and there's no direct correlation to relay. It's only the load flow analysis, or there are various statistical tools which gives a direction, and accordingly this generation is surplus. Now, having in between that peak utilization, where you have varying in peak load demands in the one side, at the demand side, and so as the generation has to cope it up in making sure that grid doesn't come out of service. So whatever sorts of vehicles, if they are hooked up to the network, they'll do their role play. And that's where the software algorithm, along with V2G, depending on the way vehicles are connected, hooked up to that grid, they will perform to the availability of what they have been mandated by the end user, by the users, as long as user have role to play. That suppose I'm the user having my car of 40 kilowatt hour battery, and I say, okay, I'm ready for 20 kilowatt hour worth of my energy to just trade. So vehicle basis its onboard charger and availability demand on that side, along with the communication protocol, can take out that energy from the vehicle to the grid. I'm just picking example. And a cluster of vehicles which are connected in a parking lot or in a ambient small kind of places or large offices, there are a source of so many such vehicles. So say each 20 kilowatt hour or 20 units, if there are like 1,000 such vehicles there, you have close to 20,000 units available for any time to trade. And power depends on the onboard charger. Mostly in a car, you have 3 or 7 kilowatt kind of capacity. So that becomes the translating factor, how much instantaneous power you can take. So 7 multiplied by 1,000, 7,000 you can take out. Again, as an engineering answer, I assume that's an engineering question.
That's good. That's
just
good.
like to add on that is that you need to have a proper market design. Like when Mr. Shukla was saying like that, this car will come and that can provide their own power to the grid. The thing is that it will not be done in a real time, right? You will have a proper day ahead, not a market, at least a day ahead before you can declare your feasibility or viability of providing power to the grid. That can be done. Because in real time, it's very difficult. You cannot ask someone, okay, you are there, you can go to the charging station and put the power in the grid. So if an aggregator puts a day ahead call, and if that the resources can be procured a day ahead, and at a single point of time, I think with OSCP and other, if electricity availability is already being forecasted on a 24-hour basis, day ahead basis, then I think that can also be forecasted on a 24-hour basis. What should be the power that need to be going to the grid at that point of time, because it will be a resource. And if you're connecting to the distribution or transmission grid or to the grid, or not to the only distribution or transmission, if you're even connecting it to the any grid, you need to have a proper planning for that, how the resource will be utilized. It cannot be like a real-time platform and you are going at that, because the battery capacity is very low for any EV. So it will be aggregating, have a huge impact on the grid. It needs to be done, it needs to be aggregated in a proper manner before going to that. Similarly, in case of peer-to-peer also, if an aggregator is coming with few or 100 rooftop solar, and when the peer-to-peer market will enhance, if they are also coming with single customer without being a single customer, that needs to be done. Because there are various, when we are doing this blockchain project, when EV charging stations and rooftop solars are being included, we need to take care of various regulatory aspects that were not there right now. Because you need to be incentivized, you need to implement penalty also. Because if a prosumer is saying that I will be selling this power at this point of time, if he is not selling that amount of time or injecting into the grid that amount of power, then what will happen? So those amount of provisions also need to be there, and the proper market design has to be there for EV, as if you are really looking for exploring this opportunity of V2G at a large scale. Thank you.
Yeah. And I think another question is,
yes,
the first question is V2G feasible for countries who do not work on peak of energy charging systems? In that case, a user is not getting benefit of contributing their car batteries in demand hours. Is a question. Any panelist can, so it's a common question. Any panelist can give that. Otherwise, I will give that.
Yeah,
I'll repeat
you
it.
can try, sir.
Yeah.
All right. One of the things I wanted to emphasize here, even when we talk about demand management, everybody thinks that it is about handling the peak demand alone. Even in electric vehicle charging, I agree that this is a big consideration. But when I look at a country like India, we don't really have this arbitrage between peak and off-peak prices, especially when it can translate to consumer tariff. To give an example, if I were to take the cost between the power plant generation during a peak hour and the power plant, the average price of power during an off-peak power, I might actually be able to see maybe a 1.5x to 2x difference. But when it translates to consumer tariff, if I take the case of Maharashtra itself, the time of use rate is only 20% higher than their tariff. So this argument of, this peak to off-peak ratio being high, being a major consideration for electric vehicle charging, to actually encourage VGI becomes a negated problem in India. We agree that is actually because our tariff is not cost reflective and we are not really able to capture the real cost. But on the other hand, especially when I look at small storages like electric vehicles, there is a huge benefit it can offer in terms of grid support. Well, the point that I am making is that I made in my presentation, again, I'm emphasizing that we should not just look at electricity as rupees per kilowatt hour or rupees per unit. There is value in reactive power. There is value in what is the power demand I can reduce, how fast I can reduce. Am I reducing it in 15 minutes? Am I able to reduce or increase it in a second? This comes in the terms of ancillary services and the balancing services it can offer. And that actually is a more value proposition that might appeal the consumer also to actually take a call to invest in the energy market. These are niche segments of the energy market, but this is perhaps where I believe in India also, because we saw the recent regulations coming in for draft ancillary services. Even though the scale needed for that is at a 1 megawatt scale, because they are looking for a bulk power system. The future might not be far away, but even the local discoms who will experience the same level of problems may procure like resources such as EVs, which is available inside their territory. There we might have a larger case.
Good. I think last question, like another question to Ms. Chandana, as she said, we have an option of 2W vehicle to provide power backup to low consumption houses and buses to the institutions. I question one question about the number of buses available for V2G service, since only school, college buses are available to provide energy to the institution. Is it really an option which can significantly flatten the peak load? Though Ruchir Supla is willing to answer the question, it is open to them.
Ruchir, I'll go first, and I think you can substantiate with the additional points. Okay. The quick answer is that I suppose the boundaries are really important. If I'm looking at a building or a house, it is what is possible within the house limit. So if I have a building integrated solar system, or if I actually have a my home integrated rooftop system, perhaps the benefit that I can get from the vehicle, be it a two-wheeler or a school bus in itself, is actually in terms of what is possible within the boundaries of the institution. This might be actually connected to the grid. It might have zero interactions with the grid at all. Maybe there are benefits coming from the institution being able to reduce their load during a peak hour. And if there is an incentive for that, we'll definitely benefit from that. Why I mentioned school buses as an example is because there was a project called Parker Project. If you want to read more about it, you can go through our report, wherein they had tested out school bus electrification, though it is not considered yet in India. This is a trend that we are observing globally. And school buses are considered as a good option, and there have been pilot projects, including the Parker project that I mentioned, where they have looked at the benefits that is possible within the boundaries of the institution itself, and they have also gone beyond. As in, can this integration of buses, there were about 40 buses in that project, can it actually provide frequency regulation services? So this is something they have tested out. That is why I just used as an example. I was not trying to say that, you know, all the public sector electric buses we are coming out in India, whenever they are charging at the night also, they cannot be used as V2G resources. So I was just using it to emphasize my point. Over to you, Richard.
I think you very well summarized. It's basically a fleet of buses in various services. So some are available during daytime, some are possibly available in nighttime. So even we take a intra-city, intercity combination of buses, you have a night service where long distance buses go while city buses stand in a parking lot for charging. On the other end, daytime buses possibly are used for charging, not necessarily directly from the grid, but through the renewable sources. And if not the whole energy, and as we see that battery prices constantly go down, maybe viable for people to really take a little higher battery. Today, our call is that take the minimum possible battery, and that's where the trade-off. So down the line, there may be situations where we have a much higher battery at dispensable rate, and we keep it as a reservoir and use it for trade. And that's the way model is looking at down the line.
Yes. Then last question is that, one second. The last question is that, one second. I think one more question was whether V2G technology is available in India. Somebody asked question. Okay, one second. Yeah, okay.
Yeah, that question has been answered. by Ruchi's.
Okay. What is the energy efficiency we consider in charging EV and taking it back to the grid for making equations viable? I think is to anyone can answer that. Otherwise, we'll answer. Yeah, kindly.
So typically, in battery storage, round trip efficiency, basically charging and again discharging. But on a grid scale, we have seen somewhere around 86%, 86 to 87% maximum. Yeah, because there is air conditioning and everything involved in the grid scale level. When you're talking about specifically for vehicle, when it is a small scale, then the losses will be lower, but typically again that would be in the range of 94 to 93% maximum. So there will be still loss of energy efficiency, because already when you are converting from grid to the battery, when you're charging, the best efficiencies are 96%, 97%, which we have been already delivering in the field. But then again, reverse, when you are doing back again, then another 4% kind of loss is expected, given the bidirectional flow. So yes, there is a inefficiency of such kind of round trip energy circulation. But I think I'll come back to Chandana ma'am and Ruchi's topic. It's V2G is a topic not only to see how we are, like say, flattening the curve or something. It is more to make that electrification of the mobility and also electrification of different appliances, be it in the home or be it in the campus, more affordable. So the total cost of ownership, by reducing the average energy cost consumed and everything, you can bring it down. Basically, you are using the battery as one of the energy source for your other application, be it vehicle to home. You are using it for your very small scale lighting applications, or when it is vehicle to a grid, you are trying to do it as a different revenue source for frequency. Basically, you are making sure that the cost of energy used for that mobility or that particular application, total cost, is coming down, and that becomes much more better value proposition than looking at one application towards whether flattening the kind of grid curve or making sure we are providing frequency regulation services to distribution companies on feeder level or not. But that's where I would go. Yeah.
Good. Thank you very much. And the final question is that as customers look at their own benefits with, sorry, that is, okay, that is removed, Anand. I was about to.
Yes, I believe Sudhasta sir answered that. If he would like to answer it live also, he can.
Okay. Actually, sir, it was removed because I answered it on this chat box.
Okay. So thank you, friends, and it is a wonderful thing that we try to open up that particular things, which is it is good that we started this discussion when we compare with other domain like metering or substation automation or SCADA and other things. This has taken up considerable progress, because here I see that many organizations are very actively participating. So when we talk about V2G, the similar thing when compared to other things, it never happened like this so fast. So things are happening. So we need to discuss. It is going to be a reality that V2G is going to be a reality, because the number of vehicle going to be added in another 10 years time down the line is a mind-boggling, because all the manufacturers have kept that certain percentage of vehicle will go as electric vehicles. That is a huge numbers. Whether we like it or not, it's going to come. So that vehicle can come to this one, and the daytime they can able to charge it at a very low price and make it available at the evening for 6 to 9 or whatever time you need it. It's going to be a great change, because as of now we don't have a viable storage option excepting batteries. We don't have many pumped storage. In other countries, they have designed it. When they've designed a smart grid, they designed first with this pumped storage. Talks about 2,000, 3,000 megawatt. That kind of storage, still it is the highest the largest storage available. The batteries, it cannot go even very closer to that. So at these conditions, this is going to be a reality. The vehicle numbers are going to increase, the batteries are going to increase, and the daytime the generation is going to be a reality, and the efficiency of the panel is increasing, and that capacity of batteries also increasing. So it is a win situation is coming. So it is a reality, and we are talking at the right moment, though it may take a little more time for V2G, the development of standards, all such things, but it's the right time to open up these things. So friends, we have done it, and we also need, it is my experience that especially with utilities, we don't say anything like that, but it's a specialized field. So our effort should be to sensitize, because it is not the one standard is involved here. At least there are a dozen number of standards involved. It's not a small equipment. So we need to sensitize, the stakeholders, especially with this major stakeholders, the discoms, where this charger are going to be connected, and they are playing a very, very important role. So we need to sensitize the discoms about the nitty-gritty of the standards. Whether we talk about the communication standard, or we talk about even the vehicle standard or connector standard, everything, we need to sensitize that. And in fact, we need to conduct a large number of conferences like that, so that the standards should go into the part of their procurement process, so that it will not find it difficult later on discarding some of the equipment like that. So in that direction, I am seeing this electric vehicle charging infrastructure or standards is going very fast. I am very thankful to all the panelists, which they are all playing very active role, whether sponsoring the projects well in advance, and some people are working on this domain itself. So the panelists well balanced panel. I am very thankful to individual friends, panelists. I am thankful to being in the offer. Thank you very much. Thank you very much.
Thank you, everyone. Thank you, sir.
Thank you.
Thank you.
Thank you.
Thank
Have a
you.
great evening. Thank you.
Thank you. Thank you very much to all our panelists for the wonderful and insightful session, sparing their precious time and extending their support for this event. I would like to thank each and everyone who joined us today. So with this positive note, we are ending today's event and promise you to come back soon with more knowledge-driven webinars. Till then, goodbye, and most importantly, keep yourself safe. Thank you.
Thank you.
Thank you.